Hi viewers, welcome to Global Positioning System, a series of lectures on GPS. In the very first initial part, I'm going to discuss about the applications of GPS. Hi, I am Professor N. Dinesh Kumar, working as Head of Electronics and Communication Engineering at Vignan Institute of Technology and Science located in Deshmukhi village, which is very near to Ramoji Film City, Hyderabad. So there are wide ranges of applications that we can use or what that we can use with GPS. We generally know that GPS is a very small device which knowingly or unknowingly we are using in our day-to-day life. But there are few specific applications which can be used anywhere or anywhere in our applications in real time or day-to-day life. Such applications are surveying, mapping, geographical information system. In short, it's called as GIS. Precision approach aircraft landing system, military and space applications, intelligent transport system, marine applications, farming or in a simple way agricultural applications, and telecommunication applications. In this particular video, I'm going to discuss about surveying. How GPS can be used in surveying. Surveying is an art of determining the relative positions of different objects below or above the surface of the earth by either direct or indirect measurements. The distance between the objects can be measured and thus a map to any suitable scale is prepared. Applications using GPS surveying with the latest advanced tools and equipment can estimate GPS coverage and can determine the position with an accuracy of centimeters. So, if you want to map or if you want to go for a map of a particular area, it can be done in two particular ways. There are two broad ways that can be classified. One is absolute positioning, other is relative positioning. Let's start with the absolute positioning. Absolute positioning is a particular position where you are going to measure how the land is going to be. It's not related with something else. It's only related to that particular position. You are not comparing that position to any other position. Whereas when it comes to the relative positioning is something where you are going to compare, you are going to process it, and you are going to compare with some other reference thing. So relative positioning, there are three ways of surveying techniques. The first one is static and kinematic GPS surveying technique, which is a high precision technique based on post processing of the carrier phase measurements. That is, once you measure some value, once you get some output, that has to be post processed. So it is not an instantaneous measurement. Whereas the second relative positioning method is the differential GPS technique, where instantaneously low to moderate accuracy positioning and mapping techniques based on the pseudo range measurements. So here you are going to take the pseudo range measurement, and it's a low to moderate accuracy, it's not a high accurate value. The third technique which we use is a real-time kinematic technique, which is a versatile high precision technique that use carrier phase measurements in an instantaneous positioning mode. When I say instantaneous positioning mode, there itself on an instant you are going to get your output. So DGPS and RTK techniques are widely used because they are able to deliver results in real time and are very powerful GPS positioning technologies. So we generally go for relative positioning technique. So in GPS in surveying, it can be done either on the land or underwater. If surveying is done on land, it is termed as land seismic surveying. If it is in water or under the water where the rocks has to be surveyed or some rocks has to be found, then it is termed as marine seismic surveying. So let's get into the first technique of measuring or surveying the land, that is GPS in land seismic surveying. Generally, oil and gas exploration requires mapping of the substance geology through seismic surveying. In land seismic surveys, a low frequency acoustic energy is sent down into the underground rock layers as shown in the figure. Here you can see that there is a vibrator truck which is located, which is the energy source. The source of acoustic energy is often selected to be the mechanical vibrator consisting of a metal plate mounted on a truck. So the truck here, you can see here there is a metal plate which is being mounted on this truck, and this particular plate is pressed against the ground and vibrated to produce the acoustic energy. So a powerful vibrations are being sent into the land. So they, as the signals go deep into the land, generally these signals which go deep into the land, because there are multiple rock layers under the ground, it is affected by the physical properties of the rocks. The portions of the signals are reflected back. As you can see here, the signal is coming and hitting the rock layers at different levels, and the signals are going to go back, which means the returning sound waves are being taken and is being measured at the land. So the reflected energy can be determined by specific seismic devices called as geophones, which are laid out at a known distances from the energy source along the survey line. So if this is taken as the survey line, here you can see that there are geophones which are being located here at different points from the energy source, and these geophones are what we call as a receivers, are going to record the reflected energy. Upon detecting this seismic energy, geophones output the electrical signals that are proportional to the intensity of the reflected energy. The electrical signals are then recorded on a magnetic tapes for geophysical analysis and interpretation. This is clear that maybe it is clear, very much clear, that unless the positions of the energy sources, here the red signals, the red symbols which are being shown are the receivers, unless we know the positions of those energy resources where we have taken is accurately measured, then only the red seismic energy reflectors are useful. Otherwise, the very expensive seismic data, whatever is being measured, becomes useless. So GPS is used to provide the positioning information in a standard or a user defined coordinate system. The integrated GPS or GLONASS and GPS and digital barometer systems have been used successfully in situations of poor signal reception. So in a very similar way, let's get into the second type of seismic surveying, which is a GPS in marine seismic surveying. So marine seismic surveying is similar to the principle of land seismic surveying, that is, the low frequency acoustic energy is sent down into the subsurface rock layers and is reflected back to the surface to reveal the information about the composition of the subsurface rocks. So depending upon how much depth the water is, different methods of marine seismic surveys are used. In deep waters, the seismic vessels tow seismic cables known as streamers, which contains devices called as hydrophones. They are very much similar to the phones what is being used in the previous land seismic surveying, which are geophones. In a very similar way, here we are going to use the hydrophones, which are used for detecting the reflected energy. So as you can see from the figure, a ship is being taken, or a ship will contain the air guns, which is going to release the energy, the low frequency energy, which I am speaking about, the low frequency acoustic energy, which has been sent into the water. Depending upon the rock layers which are present in the water, the signal is being reflected back, and the streamer which is being containing hydrophones are being collecting those reflected signals. So those signals are going to be recorded and can be further used for calculating. So this particular figure gives even more clear picture of that particular marine seismic surveying. So here you can see the survey ship, which is going to have a air gun, which is the actual source of shock waves. It is going to send all those signals into the sea. As you can see that initially the signals which will be sent will be of low frequency and even a low maybe the low intensity. Once the signal goes into the sea, the fish which are near to that particular area, after sensing this particular shock waves, they move away from this particular region. Once they move away from the region, and after certain time, the air gun is going to send the more intensity shock waves. So this is how they send the shock waves, thus not affecting the fish which live in this particular area. So once these signals go deep into the water, there will be different layers. The sediment rock layers are uniform, the impermeable rock layers, there will be waters. So it is going to be reflected back depending upon the layers which it is going to be encountered. And at the bottom there can be oils or other particular water layers or any other areas which will be reflecting the signals, and the hydrophones which are being placed on the streamers are going to collect those reflected waves. So those waves are going to be recorded by the hydrophones. So generally a single vessel will normally tow 4 to 8 parallel streamers. Each has a length of several kilometers. So at a particular instant you will be measuring maybe kilometers of sea area, or you will be surveying kilometers of sea area. So in shallow waters both the land and marine methods are used, because generally in shallow waters, I mean to say it's a deep of less than 50 meters or 60 meters. If it is more than 50 or 60 meters, generally the ocean bottom cable, which is generally called as OBC survey, is relatively new technology that is being used recently for that particular depths. In these methods, hydrophones and geophones are combined in a single receiver to avoid water column reverberations. So generally this is how a streamer will be there. Each streamer can have 6 to 8 channel streamer will be available. A tail buoy is one which is going to indicate that is the tail of the streamer. So that's a general indication. So all these reflected waves will be taken care by the streamer in recording that. So to obtain a meaningful results in whatever seismic surveying that is being done, the position of the energy source and the hydrophones must be known with a sufficient accuracy. If that is not known, the cost of all this surveying will be of no meaning, or it will be waste. So this can be easily achieved at a lower cost with GPS. Moreover, it is possible to revisit the points precisely with the GPS waypoint feature, where you can go to the exact location where we have measured. Thus we can once again check whether the same accuracy is being obtained or not. This is very much required because the marine seismic surveys is very expensive, so the issue of quality control is very much essential. To maintain the quality control, the seismic industry has suggested the use of 2 independent positioning systems. One is GPS, which is going to be the primary one. The other can be any other type of positioning system. Either it can be GLONASS or any other thing, but the GPS is going to be the primary one which will be used here. So you can have even a further more idea or how it is being measured if you can watch these videos. So I have just given a link to the videos on surveying. You can watch it for further understanding. So these are the references which I have taken. The basic reference is Introduction to GPS, a textbook by Ahmed Rabani. So the other two are the authors who have done research on, many people have done research on this particular land surveying and the marine surveying, but these two people especially has done some oil and gas exploration and how the environmental sensitivity is being measured. So I have taken the references from these two authors also. So you can refer to these authors or you can refer these papers. So thank you. If you have any doubts, you can get back to me at dinuhai@yahoo.co.in.